Under the cover of the Arkhangelsk taiga lies Plesetsk, one of the largest cosmodromes in the world and also the most northern. It was built in 1960 as a base for intercontinental missiles. It was meant to be lost on the pages of secret documents. Even the roads were masked, protecting against filming from the air. But today, this is not just a military facility. It is the most important test, research, and of course, launching platform in Russia. To date, the Baikonur has produced nearly 1,600 launches, checked 11 missile systems, and occupies a territory of 176,000 acres. The platform has launch complexes for the main Russian rocket carriers: Molniya M, Soyuz, Cyclone, Rakot, Cosmos 3M, and missile complex Topol M. But that's not all. This is where Russia has the opportunity to deploy its rockets into geostationary orbit at minimum cost. Before, all the heavy rocket carriers started from Baikonur, located in Kazakhstan. All these huge buildings behind me are just the tip of the iceberg. The Universal Launch Complex of the Plesetsk Cosmodrome has more than 200 buildings and power plants hidden deep underground. The extent of all this is staggering. Long and thorny was the path of the Angara Launch Complex. The fact of the matter is that here in 1987, the construction of another rocket complex, the rocket carrier Zenith, started. But when in 1994, the country went through a fever, construction froze up for an indefinite term. It was only in 2000 that it was decided to build a new complex using the unfinished buildings of the old complex. Construction inherited from the Zenith complex did not have the required bearing capacity, so designers had to solve the difficult task of strengthening the foundations, basements, and walls of the buildings. A year and a half ago, the backlog in some areas reached semi-annual figures, and the defense minister took personal control of the implementation of the plan. The backlog was reduced, and now the Universal Launch Complex Angara is 22 kilometers of engineering networks and communications, more than 90,000 cubic meters of concrete, and 211 buildings that fit compactly on a territory of 12 hectares. The farthest point from the checkpoint is the starting platform, which houses the launch pad and the cable-filling tower. To the left of it is a firefighting station. A bit further is the entrenched command post, from where the missile is controlled. The launch complex also features a thermostating station, an oxygen-nitrogen plant, refueling unit, compressor station, and effluents. That's all, not counting the external power supply and water supply installations. I am at an altitude of 54 meters on top of a huge mountain of steel called the cable filling station. It weighs about 1,500 tons and is used for filling and retaining the rocket. The cable filling tower also performs a windproof function. Even a force 7 wind will not overturn the rocket. It is in this building that the highways of working gases, fuel supply, as well as all electrical cables and information networks are located. It's virtually like a cocoon for a butterfly, but instead of colors, our butterfly is interested in space. I, in turn, was interested in a huge metal platform at the base of the cable-filling towers. The device which we are now on is called the launch pad. This is where the launch vehicle is located at the time of launch, along with all the communications designed to prepare the rocket for the launch. The launch pad is the heart of any launch complex. Its metal cladding is like a medieval breastplate weighing 500 tons, protecting the area from jet fire during the rocket's takeoff. None of the plates are fixed and have clearances. This ensures that during the moment of dynamic impact, the expanded metal does not deform. Under the plates, there are several layers of thermal insulation. Are there any measurement devices in the launch pad itself? Yes. There are sensors, measurement systems, and technological equipment in the compartments of the launch pad, as well as in the gas duct and the cable filling tower, which are intended for the measurement of physical quantities such as dynamic effects, vibratory loads, temperature, etc., etc., etc. In general, we get a complete physical picture at the time of startup. The preservation of the launch pad during launch is provided by a direct gas duct with an exhaust gas deflector. During the launch, tons of water for cooling will be pumped there. Next to the launch pad, there is a control station for the fire extinguishing system. There are systems of water, water foam, and halon fire extinguishing at their disposal. 4 masts are charged with water and foam straitjackets to cool the ardor of rockets. In general, are there a lot or a few of launching or propulsion systems that provide the start of every rocket? I can say that Spetsstroj provided the installation of 36 technological systems for the launch complex. This includes the basic cycle preparation system and rocket preparations here on the launch complex. The main systems include a standard filling system, a liquid and oxygen filling system, a naphthol refilling system, a system providing compressed air, which includes both production and filling of compressed air as well as other working gases. There are 3 kinds of gases used here: helium, nitrogen, and air. The versatility of the launch facility allows the launch of light and heavy rockets without adjustment. In the context of military application, for example, when restoring the orbital satellite constellation, launches will be conducted continuously. That is why they are considering the construction of a second launch facility. Every technological complex and building has a backup body that provides not only flexibility but also the reliability of reinforced concrete. Victory in space is achieved by hard work on the ground. The infrastructure of the launch complex includes more than 200 buildings. This huge silver ball is the oxygen repository for 1,400 cubic meters. Why does it smoke like a tea kettle? I will ask Anatoly. Greetings. Hello. We are at the complex responsible for the filling and storage of oxygen. What we can see now is the cooling of the highways, and the liquid nitrogen turns into a gaseous state through the following blocks, which are now emitting large amounts of cold. After cooling, the vacuuming of the lines and cryogenic piping through which the rocket fuel components, in this case oxygen, is supplied to go on board the rocket will begin. Simply put, what's happening is the cooling and the pressurization of the pipe. It is cooled with liquid nitrogen, which when heated becomes a gas, thus lowering the temperature around it. The oxygen is cooled to minus 180 degrees Celsius and becomes liquid. Such low temperature is maintained by a special cryogenic pipeline during the transportation, and by the missile thermostatic system upon start. Naphtha, also known as kerosene, is also cooled to minus 15 degrees Celsius. This is done to reduce the volume so that way more will lift. The rocket also uses helium for the pressurization of the tanks, which compensates the excessive pressure in the voids in the rocket carrier. Roughly speaking, the missile resembles a plastic bottle of soda upside down. If you press down on the space that no longer has liquid, the bottle will crumble. But in the rocket carrier, parallel to the burning fuel, helium is released. That way, everything will be fine. So what other constructions are there on the territory of the launch complex? The main structures through which the oxygen is supplied on board the rocket are underground, and that's where we're going. We're going underground? Come on. The so-called technological caves can be accessed through protected entrances. The use of underground space for technological needs is an industrial necessity. You could not fit all the gas storage, compression highways, and other areas on the surface. The lowest level of underground utilities is equal to the height of a 6-story building. All the underground constructions communicate with each other by means of channels spreading more than 5 kilometers in length. The bundling of the buildings was carried out in order to improve safety during the launch. After all, a rocket is first of all a huge tank with hundreds of tons of explosive substances. We are in the communication channel, right? Yes. This is the pipeline through which oxygen is supplied to the launch vehicle. Am I right? Yes. Yes. So there's not only oxygen here, we can also see compressed air, oxygen, and nitrogen. Everything goes along this communication channel, enters the room and the space of the launch complex, after which it spreads to the docking device to which the oxidizer or oxygen is connected, and finally pumped on board the rocket. Underground, there are a number of interesting buildings, such as the compressor. You can shout at the top of your lungs, but nothing will be heard because of the hum of machinery. Because all the controls on the launch pad are either electric or pneumatic, this is the place from where the working gas that ensures the mobility of the joints of our cosmic beast is fed. This room is a huge cryogenic plant. Yes, this is the room through which the oxygen from the storage facilities is passed by pipeline to the docking device and then on board the rocket. So, that means that all of the oxygen is concentrated here, cools, and then is fed to the rocket from here. Yes, yes. I understand that this is, in general, a very explosive production. Yes, that is in the case of an oxygen leak or fire. It can be a very dangerous environment. That is why there are showering stations provided here. Are they working now? Yes, they work. So let's check them. Maybe? Let's go. So how does this machine work? You're on fire and you run there, God forbid. That is, of course, if you're really on fire. There's the water, right? Right, good. So I'm on fire. Here at this end, that's all? Now stop. Get out of here. It pours. That's all. Of course, the fire's put out and you are saved. That's it. I got it. So I'm generally saved. After such water treatment, I need a bit of fresh air. Where is it? Well, let's go. Here's the exit.